This is quite simple, very, very easy, but just testing our understanding of core principles as defined in the theoretical analysis of what we've been talking about so far. So please look at this and let me know what we should do.
Okay, we know that what is the magnitude of P in the diagram shown below.
Yes.
But we know it's balanced. Okay, I have an idea, which is, since we know that we first find the moment of this 40 newtons downwards, and it should be equal to the one upwards, right?
Okay. So first, we are taking moment. About what point are we taking the moment?
From the fulcrum at the left.
Okay, ideally, we should know that for the fulcrum, since the fulcrum is here, and we are seeing that the body is expected to be in equilibrium, definitely there will be a reaction at that fulcrum. Okay. So yet, we say we want to take moment about this point. That is quite good because it will knock out the reaction at that particular fulcrum, which we don't need anyway because nobody is asking us to evaluate that, okay? So, good. We are taking moment and it is about the fulcrum, okay? So, I'm with you. Let's go. Let's shoot.
So, after that, finding the moment of that would be 800.
So let's take our clockwise and counterclockwise, okay? So we are coming here first, right?
Yeah.
So what is going to be the direction of this, clockwise or counterclockwise?
It's going to be, this one will be clockwise.
Okay, so this is going to be clockwise. And what is the distance?
The distance is going to be the 20.
Okay, okay. All right, so done and dusted. Now, next.
Next is this. So for this, I'm not completely sure, but since we know it's going to be force times the perpendicular distance.
Okay.
The angle. Either that or we are also looking for something where the moment should be equal to that, no, where the force produced should be equal to 40.
Okay, okay.
Not completely sure.
So I love the fact that you're able to reiterate and recall that our definition for moment is actually force times the perpendicular distance. So if they are this specific to ensure that we are talking about perpendicular distance, for me, the question is that what happened to other distances that are not perpendicular? Then definitely those distances are not going to feature in our equation. Permit me to rephrase that statement. What happens to forces that are not acting in a perpendicular direction to the point of axis? Those set of forces are going to be knocked out of the equation. So the other time, if you recollect, I was drawing your attention to the fact that notice we are talking about right angle, okay? So for this particular point P, the force P, the tension that's being exerted on the string attached to the particular beam, that means we need to combine our knowledge of resolution of forces with moment in this particular case. Is that tinkling a bell?
Yeah.
Okay, so I can say, oh yes, I think I know where you're coming from, giving me something like this. Then I should be looking at the horizontal and the vertical axis. Is this making sense?
Yes.
Okay, so if this is what I'm looking at, then I know inherently I'm going to have an horizontal component of the force P, and I'm also going to have a vertical component of that force P. So what's going to be the value of these vertical and horizontal components? You remember in equilibrium of forces, we're saying this is the magnitude, right? But then we'll have some other horizontal and vertical forces that magnitude can be resolved into. This is a classical example of such. So with this angle 30, so what's going to be the value of the vertical component and the horizontal component? Okay. I'm all yes. We talked about this.
The vertical component will be 40. Wait, yeah, it will be vertical component is sine of the angle.
Okay, so I was drawing attention to the fact that if your angle is being taken to the horizontal, then in that particular case, the vertical will be P sine 30. And what's going to be the horizontal? Are you with me there?
Yeah, I am.
Okay, quite clear, right?
Yeah.
Okay, so if it is this clear, again.
Wait. Okay,
right.
Yeah, it makes sense.
It makes sense, yes. That's the sense I actually wanted to make.
Okay, but we are unsure of what P is.
Yes, that's
wait, we know P sine 30 is equal to 40.
Okay, yes. Very good, quite good. So that's why I took my time to let you remember that there is a reaction at the fulcrum. Did you see that?
Yeah.
So if you want to go by our rule of thumb, first, the sum of forces in the upward direction is the sum of forces in the downward direction. And then the sum of clockwise moments, the sum of clockwise moment is equal to the sum of counterclockwise moment. Now, let's identify this, all of this. Don't let's yet look for solution. So, which are the upward forces?
It is RF and P sine 30.
And P sine 30. So, that means what you're having is that RF plus P sine 30 is equal to 40, right?
Yeah.
Yes, that's all you're having. So, that's one. Then, the moment.
The moment would be P sine 30. Or we can go from left to right. So there'll be 40 multiplied by 200. Wait, RF plus P sine 30 should give us 40. Yeah. So okay. Clockwise would be.
So first, I want you to identify P sine 30. In what direction is it going to go? Clockwise or counterclockwise?
It will go counterclockwise.
Okay, so this guy is acting in this. And what is his distance to the point where we are taking our moment?
It is 50.
50 centimeters. Good for you to be able to get that out. So we've gotten this. Can we get this other one now? The sum of moment in the clockwise direction is equal to the sum of moment in the counterclockwise direction. Okay, so clockwise, we have 40 multiplied by 20, right? Is equal to, that's the only clockwise that we have here, okay? Is equal to, now, the one in the counterclockwise. What is the value of that one in the counterclockwise? The distance is 50, okay? So what's the value of the force now?
50 into P sine 30.
Okay, I need you to be quite on point there. That, please, for the sake of emphasis, permit me to just raise it again. We are only looking for the product of force and the distance moved in the perpendicular direction to that force. So we are looking for this right angle. We're always looking for this right angle. All right. So it is this. So that means that our P that we are looking for is actually 40 times 20 is 800. 800 over 50 sine 30, right? and that's 16. So we have 16 over sine 30. Sine 30 is half. 16 over half, that is 32 newtons. Okay. So, well, that is what we are actually asked to evaluate. But I didn't mean that we're interested in finding RF. We can take it a notch further and say that RF is going to be 40 minus P sine 30. P sine 30 will be 32 sine 30, and that is 16. 32 sine 30 is 32 times 0.5. So this will be 24 newtons.
Yeah.
Okay, so I think with this we can call it quits with respect to moment. Okay, I think we've exhausted quite all that they might be asking of us